All right. Wait, guys. Okay. Okay. So let's continue our lesson. Okay. So last time we already covered until binomial distribution. So now we want to know what is normal distribution. Okay. So the next distribution that we will talk about is normal distribution. Okay. So this one is also okay. This one is one of the most useful distribution under continuous distribution, continuous probability distribution. Okay. So for discrete distribution, okay, we have binomial distribution. Okay. So and then for the continuous distribution, we have normal distribution. Okay. So these two are the most common distribution that we will encounter. Okay, when we talk about probability distribution. Okay. So what is normal distribution? Okay, so normal distribution is the most popular and useful continuous probability distribution. Okay, and then the normal distribution is defined as this is the function of normal distribution. Okay, so these are the general function for normal distribution. Okay, this one is just for your knowledge. Okay, so the function of normal distribution is 1 over standard deviation multiplied by square root of 2 pi, okay, and then multiply by epsilon to the power of negative x minus mean to the power of 2 divided by 2 multiplied by variance. Okay, so this one is standard deviation. Standard deviation square is variant. Okay, all right. So these are the function for normal distribution. Okay, so this one is just for your knowledge. Okay, all right. So the normal distribution is completely specified by the value of mean and standard deviation. Okay, so how your normal distribution looks like will be defined by your mean value and by your standard deviation value. So these two values will determine the shape of your normal distribution. Okay, all right. So these are example. Okay, so we have here. Okay, so this is your initial value of mean. Okay, so for example, your mean is 50. Okay, so you have a mean of 50. Okay, so and then you have your normal distribution. Okay, so you have your normal distribution. So this is the curve here is your normal distribution. Okay, so your normal distribution, okay, the distribution will be when you have your normal distribution, okay, your mean will be in the middle of your distribution. Okay, your mean will be in the middle of your distribution. Okay, so for example here is 50, so the peak of your distribution will be on 50. Okay, right, and then you have the curve to the right and to the left of your mean. Okay, so what if your mean change, the value of your mean change? Okay, so what happened is when when you change the value of your mean, you will shift your curve. You will shift your distribution either to the left or to the right. Okay, for example, if let's say your mean value becomes smaller. Okay, so here your mean value becomes smaller. So first the initial one you have 50. Now you calculate back your mean, you discover that your mean value, the new value, okay, your mean value now is 40. Okay, so now you see the curve only shifted to the left, to the low number, okay, to the low number, to the lower value of mean. Okay, because you must ensure that your distribution peak is on your mean. Okay, so once your mean value shifted, then you have to shift your distribution. Okay, so this is the effect of mean value. Okay, so once you change your mean value, then your distribution also will move according to your mean value. Okay, but the shape of your distribution is similar. Okay, all right. So the mean value will only shifting your distribution. It will not change your distribution shape. Okay, all right. So that is the effect of mean. But what is the effect of standard deviation? Okay, so standard deviation will affect the shape of your distribution. Okay, that it will affect the shape of your curve. Okay, so here example. So you have, this is your standard one. Okay, this is your original value of standard deviation. Okay, if your standard deviation becomes smaller, then you will have smaller distribution. Means that your distribution will become more packed. Okay, you will have steeper curve. Okay, and then the bell shape is smaller. Okay, so this is the shape when your standard deviation value is small. Okay, but if you have larger value of standard deviation, then your shape become broader. Okay, the bell shape become broader. Okay, and then you will have a much milder curve. Okay, the curve become more flat. Okay, the curve become more flat. Okay, so these are the effect of standard deviation value to your normal distribution. Okay, all right. Okay, so normal distribution is symmetrical with midpoint representing the mean. Okay, so like I said before. Okay, so when we have a normal distribution, okay, the shape is symmetrical. Okay, means that the shape on the left side and the right side is similar. Okay, if let's say uh, you match the left side and the right side, it will be identical. Okay, so that is normal distribution, and then in the middle of the distribution is your mean value. Okay, so that is the what we call it, the general characteristic of normal distribution. Okay, and then shifting the mean does not change the shape. Okay, so like we already see, when the mean value of the normal distribution changing, okay, the distribution of the distribution the distribution shape of the normal distribution is maintained. Just you shifting the position of the distribution. Okay, right. Value of on x-axis measure in the number of standard deviation away from the mean. Okay, so the shape of the shape of the distribution is determined by the standard deviation value. Okay, right. So why we have this curve? Okay, because this curve represents the value of x. Okay, this is the value of x. Okay, so the x value will be determined by the distribution based on standard deviation. Okay, so how far the value of x from the mean will be determined by the value of standard deviation. Okay, all right. As standard deviation become larger, curve flatten. As standard deviation becomes smaller, curve becomes steeper. Okay, so here. So if the standard deviation larger, then you will have a flattened curve. Okay, but if you have a small standard deviation value, then your curve become steeper. Okay, why? Because when you have a smaller standard deviation, it means that the value of the x
is near to the value of the mean. Okay, but if you have standard deviation, if you have larger standard deviation, it means that the value of x is much further from the mean value. Okay, so that's why when you have larger standard deviation value, the shape become flatter. If you have smaller standard deviation value, the shape become steeper. Okay, become more sharp. Okay, become sharp. Okay, all right. Alright. So how to use the standard how to use the normal distribution. Okay. So we can calculate, to calculate probability from the normal distribution directly is quite challenging. Okay, it's quite challenging. So what mathematician do, what the researcher do, they create what we call as standard normal table. Okay, so using the standard normal table, okay, we can calculate the probability from the normal distribution. Okay, so we use the standard normal table to calculate probability for normal distribution. Okay, so to calculate that, we have to do some conversion. Okay, so to calculate probability using standard normal table, first of all, you have to convert the normal distribution into standard normal distribution. Okay, so we have to convert from the normal distribution that you have into standard normal distribution. Okay, so what is standard normal distribution? Standard normal distribution is the normal distribution with mean of 0 and standard deviation of 1. Okay, so to make the calculation simpler, so we create a standard. Okay, because it is hard to calculate the probability directly from the normal distribution. Okay, so what the mathematician do, they create a standard model. Okay, and then they create the step to convert from your normal distribution into standard normal distribution. Okay, so when you convert your normal distribution into standard normal distribution, then you can calculate your probability using standard normal table. Okay, so to calculate to calculate using standard normal table, first you have to convert into standard normal distribution. So how to convert it? Okay, so you have to calculate the new variable, which is z. Okay, so what is z? Z is equal to x, the value that you want to measure, minus the mean value divided by standard deviation value. Okay, for example, you have you measure, okay, you measure the weight. Okay, for example, you want to measure the weight of rice you sell every day. Okay, all right, you want to calculate. Okay, you open a shop, you sell food. Okay, you sell raw food to your customer. Okay, so now you want to know how much rice you sell every day to your customer. Okay, you want to know how much rice you sell to your customer every day. Okay, so the weight of rice you sell to your customer every day will be varied. Okay, maybe today is 1.1 kilogram. Okay, tomorrow is 1.05 kilogram. Okay, and then the next day 2.15 kilogram. Okay, so the value is, first, the value is not the value has a is not a whole number. Okay, first of all, the value is not whole number. Means that you don't have one kilogram, 2 kilogram only. Okay, you have 1.1. Okay, you have the what we call it as, okay, you have a fraction of whole number. Okay, right? So you have 1.1 kilogram. Sometimes you sell 1.5 kilogram. Okay, so the you cannot use discrete distribution. Okay, you must use continuous distribution. Okay, and then and then you collect the data. Okay, so you already know. So your distribution will be continuous distribution. Okay, so once you collect your data, okay, you find out that your data is in the normal distribution. Is a normal distribution. Is in a normal distribution. Okay, so you want to give. So you already collect the data, you already know your distribution. Okay, so now you want to calculate what is the possibility that you can sell more than 2 kilogram. Okay, for example, you want to sell more than 2 kilogram per day. Okay, a day. Okay, what is the probability that you can sell more than 2 kilogram a day? Okay, so the value that you want to measure here, 2 kilogram, is the value of X. Okay, and then the mean value will be determined by your distribution. You have to calculate what is the mean value for your data. Okay, and then what is the standard deviation value for your data. Okay, so once you have all these number, then you can calculate what is Z number. Okay, we call it as Z number, Z number. Okay, so you can calculate what is Z. Okay, all right. So that is the first step. You find out the value of Z. Okay, and then okay, so this is an example. Okay, for mean value 100, standard deviation of 15, find probability that X is less than 130. Okay, so for example here, okay, we use the same example. Okay, so you sell, okay, you want to calculate what how many you sell per, okay, you want to predict what is the possibility you can sell less than 130 kilogram of rice every day. Okay, you want to know what is the possibility that you can sell 130 kilograms of rice every day. Okay, so the value that you want to measure is 130. Okay, and then based on your data, you calculate that your mean, the mean for your data is 100, and then the standard deviation is 15. Okay, so you can calculate the Z value. So the Z value is 130 minus the mean value, which is 100, divided by 15. 15 is standard deviation value. Okay, so you get 30 divided by 15, then you will get 2. Okay, so these are the Z value. Okay, so your Z value is 2. Okay, all right. So that is the first step. Okay, and then the second step, look up the probability from the table of normal curve area. Okay, so that is the first step, and then the second step, you look at the table. Okay, so later, okay, I think in the next slide we will see how the table looks like. Okay, so based on the table, first of all, we look at the column. Okay, column on the left is Z value. Okay, and then row on the top has second decimal places for Z value. Okay, so let's see how it looks like. Okay, all right, so this is our example. All right. Okay, so these are the table. Okay, these are the table. Okay, so this is the how standard normal table looks like. Okay, so we want to calculate the probability of selling, okay, more than Z equal to 2, 2.0. Okay, so 2.0. Okay, so first you look at the left row. Okay, Z. Okay, so this is your Z value. Okay, so Z value is you look at 2.0. Okay, so 2.0 here, 2.0, and then you look to the right. Okay, so to the right, you look at the decimal places of the z. Okay, so now your z value is 2.00, right? So you don't have any decimal places, so you look at under 0.00. So 2.0, and then you look to the left and to the right, 0.00. Okay, so these are the value that you want to these are the value that you want to you want to find. Okay, so the probability of selling rice. Okay, the probability of selling 130 kilogram of rice per day is 0.97725. Okay, so more than 98% chances that you can sell. Okay, so it is 98% confirm that you can sell 130 kilogram of rice per day. Okay, right? So for z equal to 0, so this graph show you, so this table will cover here, okay, at the back. So 130 to the low, okay, to the lowest level. Okay, 130 and less. Okay, so these are the area that the table cover. Here. Okay. Oops, sorry. Okay. So these are the area that the table cover. Okay. So if you want to sell 130 kilograms, okay, means that you want to sell 130 kilogram or less lah. Okay. Because you want to see at least you want to sell what is the possibility you can sell 130 kilogram at most. Okay, right. So based on the table, it is 97.725% chances you can sell 130 kilograms of rice per day. Okay, all right. So what is the possibility you can sell more than 130 kilogram of rice per day? Okay, so to do that, you just deduct the probability you calculate in the first place. Okay, you deduct it with 1. So 1 minus 0.97725, you will get 0.02275. Okay, it means that only 2% you can sell more than 130 kilogram of rice per day. Okay, only 2% chances. Okay, so the chances to sell more than 130 kilogram is very, very. Okay. Okay, so this is another example how you calculate probability using normal distribution. Okay, so Haynes Construction Company, they built 3 and 4 unit apartment building. Okay, all right. So total construction time follow a normal distribution. Okay, all right, all right. For 3 unit apartment, the 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 mean is 100 days, and then the standard deviation is 20 days. Okay, right. So contract call for completion in 125 days. Okay, right. So late completion is incur a severe. Okay, so if the company cannot build the apartment in 135 days, then they will get penalized. Okay? The owner will penalize the contractor. Okay, so you want to calculate what is the probability you can complete the construction. Okay, before 125 days. Okay, means that 125 days or below. Okay, means that what is the possibility you can deliver the project within time frame. Okay, you want to calculate the possibility. Okay, So from this info, we can calculate the z value. Okay. So what is the z value? Okay. So from to calculate the z value, you need the x value. Okay, the x value is 135 days. Okay, this is the value that we want to calculate. Okay, and then the mean value is 100 days, and then the uh the the standard deviation is 20 days. Okay, so from here we can calculate the z value. Okay, so the z value is 125 x minus 100, the mean divided by the standard deviation 20. Okay, so 135 minus 100 is 25, divided by 20, you will get 1.2, 1.25. Okay, right? And then from 1.25, okay, so 1.25, okay, and then we look at the table. Okay, we look at the table. Okay, let me find you one. Okay, let me try to find you the table. Okay. Standard number distribution. Okay, wait. Share with you the slide. Okay. All right. So these are the table. Okay. So this is an example of table. Okay. So this is the z value. Okay, and then this is the second decimal for the z value. Okay. For example, okay. So how to do it? First, you read the z value first. So our z value is 1.25, right? So 1.2. Okay. You find 1.2 first. Okay. And then the second decimal is 0.05, right? Because 1.2, 1.25. Okay. So here is 0.00, 0.01, 0.02, 0.03, 0.04, and then 0.005. You can see here. So 0.05. Okay, so you will get 0.39444. This one is the straightforward. Yes, this one is 0 to Z. To Z. Yes, this one. Oh, okay, okay. Okay. All right. So 1.25. Then you will get 0.3944. 0.3944. Okay. So 0.3944. Okay. Right. So 0.3944. Okay. Remember that number. Okay. All right. So 0.3944. Okay. So, but here you can see here they state 0.89435. 0.3944. Okay. So 0.3944. Okay. So why it happened like that? Okay. Wait, let me share with you. Okay. So why it happened like that? Okay, because the one that we calculate is from the center to the z value. Okay, so the table that we use is from the center here, 0 until z. So we only have here. So these are the value that we calculate. So 0.3944 is from 0 until the z value. Okay, so 0.3944. So what you should do, you have to add the value at the back here. Okay, so because we want to know the value from the day one until day 125. Okay, we want to know what is the possibility of the possibility we can complete the job, okay, before 125 days. Okay, so we have to calculate, we have to add another part at the back here. Okay, so what is the value of the part at the back here? This here is half of the distribution. Okay, so if the distribution is 1, half is 0.5. Okay, so the probability for the right side, the left side here, okay, is 0.5. Okay, so and that 0.5 you just have to add to the portion that you calculate before. Okay, so that one is 0.3944, right? Okay, so 0. So here, so 0.3944. Okay, so 0.3944 plus 0.5. Okay, so you can see here 0.89444. Okay, you can see the value is now similar, right? Just this one, they have five decimal places. Okay, so but for the table that we use, they only give you until 4 decimal places. Okay, so both answer is correct, no issue. Both answer is correct. Okay, depend on the table that we use. Okay, so you get here 0.89444. Okay, so here, so 0.89435. Okay, so it's almost similar. Okay, so it means that 89.4% chances you can complete the job before deadline, before 125 days. Okay, right? So the probability is about 0.89. Okay, so that heinous will not violate the contract. Okay, so there is a possibility. There is a possibility that you can, okay, the contractor can complete. Okay, there is a very high possibility, almost 90% chances that the company and the contractor can complete the job within the time frame. It means that they will not the project will not overdue. Okay, the project can be completed, okay, within the time frame. Okay, okay, that is one. Okay, and then there is another situation. Okay, in the contract, the owner stated that if the contractor can finish the job, okay, can finish the construction, okay, if the contractor can finish, okay, if the contractor can finish the job before 75 days, okay, then they can get the owner will pay bonus to the contractor, $5,000. Okay? So what is the probability that the contractor can get the bonus? Okay, so again, now you have to calculate the z value first. Okay, so the z value is x minus mu divided by standard deviation. So x value is 75 days. Okay, and then the mean value is 100 divided by the standard deviation value, which is 20. Okay, then you will get 75 minus 100 is minus 35 divided by 20. Then you will get minus 1.25. Okay, right? So minus 1.25. Okay, so here is the area. Okay, this is the one that you want to calculate. You want to complete the job 75 days or less. Okay, all right. So based on this distribution, we can see that, okay, so one is this here is negative 1.25, right? So we already know the value here, 1.25 here, right? okay, 1.25, okay, 1.25. Okay, so we already calculate okay, the value here. So 1.25 here, we already know. Okay, we already know here. Okay, because normal distribution is a symmetrical distribution. So you have to remember that the distribution of the normal distribution is symmetrical. Okay, so once you have the value for 1.25 here, okay, so you already know the probability for here. You can just calculate the probability here. So how to do it? You just have to deduct 1 minus 0.8943435. Okay, so you will get, okay, so 1 minus 0.89435 for, okay, then you will get 0.10565. Okay, so these are the probability. So here they make some mistake lah. Okay, so suppose you have to 1 minus 0.89435, then you will get the value. Okay, right. So the possibility of getting the bonus is only 10%. It means that it is less likely that the contractor can complete the job, okay, within 75 days. Okay, so it's very unlikely. It's only 10% chances. Okay, so it's only 10% chances. So it's, the chances is very, very low. Okay, it means that it's almost too impossible that the contractor can complete the job within 75 days. Yes, right? Okay, oh, so sorry. Okay, so here you can calculate the, okay, you can calculate the case no sheet. Sorry, I only, okay, this one is only half of the calculation. Okay, so to calculate the value here at the back here, because you already have the value for the area here, right? You already know the value for this area, so you just have to deduct 1 minus the area here, then you will get the area at the back here. Okay, so you get the chances for the contractor to complete the construction within 75 days is only 10.5%, 10.565%. So less than 11%. Okay, so it's very unlikely that the contractor can complete the job within 75 days. All right. Then another one. Okay. So what is the probability of completing between 110 and 125 days? Okay. So you want to know what is the potential that you can complete the job within 125 days, and okay, you can complete the job between 110 days and 125 days. Okay. So you have to calculate the, okay, so you have to calculate the probability between 110 and 125 days. Okay, so to calculate that, okay, we already have 125 days. Now you have to calculate for 110. So 110, so we have to convert it into Z value first. So how to do it? So x minus mean divided by standard deviation. So x value is 110 minus 100 divided by 20. Okay, then you will get 10 over 20 or 0.5. Okay, so for 0.5, okay, look here. So 0.5. So here, look again. Okay, so you use the table here. So Z is 0.5, 0.5, okay, 0.50, right? 0.500. Okay, so here is the value 0.19115. Okay, all right. So 0.1915 here. Okay, and then we have here is 0.3944. Okay, so here we already know, so here is 0.199. So from here, from the 0 until 125 is 0.3944. Okay, so to calculate the area between 110 and 125, we just have to deduct the probability between the probability of 125 deduct probability of 110. Okay, so to do it, okay, so 0.3 0.3944, sorry, 0.3944. Okay, so 0.3944 minus, let's see here, 0.1911, 0.1911, and you will get 0.20229. Okay, right? See, 0.89435 minus 0.69146. Okay, so we will get 0.20229. Okay, so these are the probability for, okay, these are the probability you completing the job between 110 days and 125 days. Okay, 20% chances that we can complete the job. Okay, last minute. Okay, at the end of the, we will complete the job at the end of the contract. Okay, at the end of the video. Okay, so only 20% chances. Okay. All right, so these are the table. Okay, so this table is quite different. Why? Because this table is calculating from the back here. Okay? The table that we use, okay, so this table we use is from the middle, okay, here. So from the middle to the, okay, we can, okay, if you see here, from the middle, from 0 to the z value. So these are the table that we use down there. Okay, but the table here, okay, so for this table they calculate differently. They calculate like this. Okay, they calculate from the lowest number until the z value. Okay, so you can see here it's different. Okay, so we have several type of table we can use. Okay, so you have to check what kind of table you have. Either it's from 0 to z value, or from the lowest value to the z value. Okay, or from the another table we have is z onward. Okay, so this one we look from the bigger than. Okay, so for this table we look at the probability of value bigger than z, bigger than value that we want to calculate. Okay, so there are three type of standard table. Okay, so we usually the table, okay, usually the table will give you the information what kind of table you are looking at. Okay, so there are three type of table. Okay, right? Okay, so this table is up to z. Okay, so you see here there are three type, right? From 0 to z, up to z, and z onward. Okay, for this table is from 0 to z, from 0 to z. But for this one is up to z table. Okay, so this is a different table. Okay, all right. So this is how you use Excel to calculate normal distribution. Okay, you can look at the slide later how they do it. Okay, all right. Okay, that is how we calculate distribution. Okay, sorry, probability using normal distribution table. Okay, so because it is not easy to calculate the probability using normal distribution. Okay, the mathematician they come up with some rules that we can use. Okay, this is like a is a rule to simplify your calculation. Okay, what is the rule that they highlight for normal distribution? For normal distributed random variable with a mean u, okay, and then the standard deviation sigma, approximately 68% of the value will be within plus minus one standard deviation of the mean. Okay, and then approximately 95% of the value will be within plus minus 2 times standard deviation of the mean, and that almost all 99.7% of the value will be within plus minus 3 times standard deviation of the mean. Okay, so this is the standard distribution for normal distribution for the normal probability distribution. Okay, so when you find, okay, someone said that, okay, the data is normally distributed. Okay, so you can say that almost 68% of the data is within standard deviation, okay, plus your mean value. Okay, means that the almost half of the data is within the range of your standard deviation. Okay, almost half of the data is within your standard deviation range. Okay, and then 95% of the data is uh, within the 2 times your standard deviation, and then almost all data, 99.7% of the data, will be within 3 times of your standard deviation range. Okay, right. So these are just the basic, just a very basic rule of thumb, lah. Okay, right. So this figure show you the sorry. Okay, so this figure show you the rule that we already taught, right? Okay, so this is your mean, and then this is your standard deviation. Okay, so the above limit and the lower limit of your standard deviation, it will contain 68% of your 68% of your data. Okay, 68% of your data will be here. Okay, and then the rest is okay. And then on the left side, you have 60% of your data, and then on the right side, you have 60% of your data. Okay, and then if you, okay, for range, okay, for range of double your standard deviation range, it will contain 95% of your data. Okay, only 2.5 data will be out of this boundary. 2.5 data will be out of this boundary on the right side, on the left side. Okay, and then almost all the data, 99.7% of the data will be within 3 times the boundary of your 3 times of your standard deviation value boundaries. Okay, so only 0.5% data on the right and 0.5% data on the left will be out of this boundary. Okay, so these are the standard distribution in normal distribution. Okay, all right. Okay, okay, guys, let's take a short break. Okay, let's take a 10 minutes break. Then we will continue with the next distribution. Okay. Okay, right. So let's continue our lesson. Okay. Mm, ah, ah, Okay. Wait. Let me open this. Sorry, suddenly my slideshow stuck. Okay. All right. So let's continue. Okay. All right. So that is the normal distribution. So binomial and normal distribution is the most common distribution that we will encounter when we do quantitative analysis. Okay, so we have another type of distribution under probability distribution. Okay, but this one is only for your knowledge. Okay, so I will just go very fast. Okay, that's for you to know. Okay, all right. So the next type of distribution is what we call as F distribution. Okay, so F distribution is a continuous probability distribution. Okay, the F statistic is the ratio of two sample variance. F distribution have two set of degree of freedom. Degree of freedom are based on sample size and used to calculate the numerator and denominator. Okay, so we have first is df1 and df2, degree of freedom for numerator, and then df2 is degree of freedom for the denominator. Okay, the probability of large value of f are very, very small. Okay, all right. So this is example of f distribution. Okay, so for normal distribution, the shape is what we call it the name the shape is sorry, I forgot the name. Okay, so the shape is sorry. The shape is symmetrical. Sorry. Yes, symmetrical. Okay, the shape is symmetrical. Right. For the normal distribution, the shape is symmetrical. Means that on the left side and the right side is similar. Okay, if you put together the left side on the and the right side on each other, then you can see that the shape is identical. Okay, but for the F distribution, the shape is asymmetrical. The distribution is not symmetrical. Okay, so we have a, an asymmetrical distribution. Okay, so this is how it looks like for the F distribution. Okay, right. So this is an example. Okay, so example, let's say your df1 is 5, df2 is 6. Okay, and then your alpha is 0.05. Okay, and then to calculate this then you get the f value first. Okay, based on these three parameter, you get the f value is 4.39. Okay, and then from the f distribution table, you get the probability of f is greater than 4.39 is 0.005. Okay, all right, so this is just example. Okay, right, so I will not go too deep for this one because this one is not common. Okay, we did not see this. We did not use this distribution frequently in the business world. So that's why I will not go too deep for this type of distribution. Okay. And then we have exponential distribution. Okay, for exponential distribution, we call it as also as negative exponential distribution. Is a continuous distribution often used in queuing model. Okay, all right. So these are the function for exponential distribution. Function function of x is equal to the mean multiplied by epsilon to the power of negative mean multiplied by x. Okay, all right. So this one only used for queuing model. Okay, for logistic. Okay, so this one also is not common. Okay, it's not commonly used in the business. Okay, all right. So this is an example of exponential distribution. Okay, all right. So these are the example. Okay, install. Okay, are not install no muffler on automobile and small truck. Okay, he can install 3 muffler per hour. Okay, service time is exponentially distributed. What is the probability that the time to install a new muffler would be half an hour or less? Okay, all right. So the x value is half an hour. Okay, and then the mu the average is the average number of unit is 3 per hour. Okay, here. Right, can install 3 muffler per hour. Okay, so these are the mean. Okay, and then the x value is 0.5. Okay, and then to calculate the probability of installing muffler less than half an hour. Okay, so you have to find the probability x is 0.5 and then minus it with 1. So 1 minus epsilon to the power of minus 3 and minus 3 multiplied by 0.5. Then you will get 0.7769. Okay, so these are how you calculate the probability for exponential distribution. Okay, right? So these are the example. Okay, right? So these are how to use the Excel. Okay, and then lastly we have what we call as Poisson distribution. Okay, so for Poisson distribution is a discrete probability distribution. Okay, so for Poisson is a discrete, often used in queuing model to describe arrival rate over time. Okay, the function is given by the function of x is equal to the probability of x is equal to average number of arrival per unit of time to the power of x, and then multiply by epsilon to the power of minus lambda divided by x factorial. Okay, all right. So these are example of Poisson distribution. Okay, all right. Okay, so I'm not going too deep for those three distribution because we will not see it frequently in the business world. Okay, only binomial and normal distribution is the most common distribution that we will encounter in the business world. Okay, all right. Okay, I think okay, so I think that's all for this topic. Okay, so we already completed chapter 2.